All right, so that looks like everyone. So again, just a reminder that if you did not get 5 out of 5 on the bonus logic puzzle points, that because deductive reasoning is such an important skill to develop, you can go to Canvas, follow the Puzzle Bear and Logic Puzzle link. Make sure that you sign in, no hints, no check for answers, basically no penalties. Solve 4x4 logic puzzles at any level, including easy. Take screenshots of those and then just upload those screenshots in Canvas. You will see the exam logic puzzle assignment tab, exam 2 logic puzzle assignment tab, and upload those and refer to the previous lectures to show you how the progression works. But basically, whatever points you're missing, so if you're missing 1 point because you got 4 out of 5, if you're missing 3 points because you got 2 out of 5, whatever points you're missing, each logic puzzle you complete will get you 20% towards the points that you're missing, right? So no, it'll actually get you 25% towards the points that you're still missing. So every time that you complete a logic puzzle, the gap towards that 5 out of 5 will get smaller and smaller and smaller. So the deadline for that is midnight, right before exam number 3, if you want to apply those towards exam 2. And I actually will be updating exam 1 grades either tomorrow or on Monday to reflect the logic puzzles that people have submitted for the exam 1. All right, so what we're going to do today is we're going to take a look at understanding research results, statistical inference in chapter 3, and all this is to get us ready for next class, which is where we are going to write our results section. So we're done with the method section. We wrote that up. Hopefully everybody's been working on their peer reviews for each other. And what we're going to do next is we're going to write the results section. So we're going to be doing that in class, and I'll have some details on how that's going to work and what goes into a results section. Briefly though, before we begin, I'm going to just remind you about the library assignment, how to read your feedback, about the peer review process that we're in and what to do after the peer review. So that's going to be a brief recap. Then we're going to take a look at the results section, what's going to go in there in terms of content, what's going to go in there in terms of APA requirements, how you should think about your results section. We'll talk about writing the results section. Attendance highly recommended, which is next class. And then we'll wrap it up with a look at inferential statistics, because when we're writing up the results section, we will rely heavily on statistics. That's where you present the statistics as part of your explaining to the reader what happened. All right, so just to make sure everybody is aware, for the library assignment resubmission, if you have a no for question number 2 on any of the criteria, so was it a recent article, was it reconstructed memory, was it a primary research article, or if you have a no for any of those criteria for 4A or 4B, recently or highly cited, group memory article or primary research article, then you need to resubmit a new article to replace the unapproved original article. So for example, if this is your feedback right here, 4A was not a primary research article, it was probably a review article. 4B was not on group memory. It probably used the word group, but it wasn't about either learning together and or remembering together. So we need to find a new article to take the place of the ones that were not approved. So resubmit these articles for approval. You have up to 3 chances to resubmit. Some of you have already submitted and gotten your new articles approved, which is great. But I just want to remind everybody that the due date for this is October 28th, regardless of how many attempts you've actually used by that time. So I will be checking today, I'll be checking tomorrow, I'll be checking on Monday to see if those, for those new submissions. But if you want to take advantage of all 3 attempts to resubmit, make sure that you get those early enough to give me some time to take a look at them and get that feedback back to you. So just want everybody to be aware of that. And then also, we are now in the middle of our peer review. And the reason that we're doing these peer reviews is we're mimicking what is done in professional psychology journals. They use a peer review process where people at your level review your work. So That's why we're having everybody review each other's work in this class. And what it's designed to do is to make your writing better. So this is basically the equivalent of going to a writing tutor and discovering or having them look your writing over so that you can improve your the quality of your final manuscript. So this is kind of a double-edged sword as well, because not only are you getting feedback from the other reviewers, but one of the best ways to actually learn how to do something is to try to teach somebody how to do something. And when you're doing your peer reviews, you in essence are teaching these other students how to do their paper, how to do it in terms of content, in terms of APA style. And that as well will help you learn APA style, learn writing skills for your future draft as well. So there's just benefits all over the place. You get to see a good example probably of the methods section. You'll probably see a poorer example of the methods section, so it gives you a sort of viewpoint about where your fellow students are at. And just again to iterate how this all works, the submitted drafts have all been placed into a pool of drafts that Turnitin draws from, and then each reviewer will be assigned 5 of those drafts at random. So you will not be assigned your own draft. You'll be assigned randomly other drafts from other students. And the way that the algorithm and program is designed, every single draft will get reviewed by 5 different reviewers. So you get 5 different perspectives, 5 takes, 5 looks on each of your submissions. And we're going to do this for the methods section. We're going to do it for the results section. And then finally, we're going to do it also for the discussion section. So in terms of the assignment, it's done through Turnitin, so make sure that you are going through that to do your methods draft peer mark assignment. That's what the peer review is called. And it's a guided review using yes or no questions. So you will see when you open up the link, it'll look something like this, where you will have the draft on one side, and then you'll have guided questions on the other side. They are questions of content, and if the content is correct, simply type in yes. If the content is incorrect, simply type in no. Or if the content is missing, also type in no. And even if it's mostly correct, but maybe not completely correct, also type in no. This is your way of flagging for the writer what it is that they need to take a second look at, what it is that they might have done incorrectly. And you'll see that for content as well as for APA style. And those are labeled, so the content questions say content, stimulus and apparatus, did they have the correct number of lists? APA will link to APA, Roediger and McDermott, citation properly formatted. So again, just let them know yes or no. And again, this will be part of your own little learning exercise as well, because in order to know whether Roediger and McDermott in that draft were properly formatted, you need to know what does a proper format for a citation look like, which again helps you learn about APA style as well. And that peer review assignment is going to be due October 28th, also at midnight. So make sure also at this point in the course, we're going to have a lot of different things moving, different pieces going on at the same time. So we got the peer review assignment, we got the library review submissions, we have journal article reviews that are coming up due. Make sure that you're aware of those due dates, plan yourself out accordingly, so that we can keep progressing towards that final research paper deadline. And speaking of that final research paper, after the peer review, make sure that you use the peer reviews. So I will be grading the drafts very, very soon, and I will grade the drafts in terms of, are they good drafts? Are they where you should be at this point, draft-wise? So the grading criteria is going to be a lot more lenient than it is going to be for the final research paper. So I don't need you to do everything perfectly, but I need to have this sense that you attempted all of the content. Maybe you're missing something, but it's not going to, I'm not going to ding you for that. I don't need you to have APA style completely down, but I need to see that you've attempted APA style. Maybe you've got the headings wrong, but the headings are there. So there's going to be very lenient grading in terms of, I'm just looking to see, is it a quality draft? Not is it a quality finished product, is it a quality draft? Are you where you should be in terms of this stage in the writing process? When you do your final research paper, it's going to be, have you done all these things correctly? So at that point, I'm going to be looking at the finished product, and that's going to be much more stringently marked. It's not whether or not you're on your way to a properly formatted APA research report. It's have you achieved a properly formatted APA research report. So use the peer reviews that you get as feedback for that. Once you get your peer reviews on the 28th, they'll be posted to your Turnitin account. If you feel that you weren't fairly reviewed, let me know. Okay, so you'll have 5 different looks at the peer review process. If one of them is in wild disagreement with the other reviewers, usually this occurs if somebody did not put in the proper amount of time to review your draft. Please let me know, because we have multiple reviews coming up. We still got the results, we still got the discussion section, and I'll have a conversation with that student just to make sure that they are doing their part for our learning community for the next go around. And just contact me via Canvas messages. You will not know which review it is, so just let me know. One of my reviews seemed a little weird. I think that maybe one of my reviews did not take the time to do it, and I will go in and take a much closer look to see if that might be the case. And then, as I said, after the review, make sure you're using that information to make your draft better. So use the feedback. Oh, I didn't format this correctly. Oh, I should have, I forgot to include this information. Use that to make your method section better. And I will be uploading these Word documents very shortly. The peer review response summaries will help you track the changes that you make to your draft and track your responses to the reviewers. So basically the way that it works is that it will have every single question that you've been asked in your review. So when you are working on your method section draft, just have this open in another window. And as you go through content, subjects, correct number of total subjects, how many yeses did you get on that? Out of the 5 people that reviewed you, how many said yes, you got that correct? If it's 5, then there's no changes needed, you got that correct. If there's 4, you might have a response instead that just simply said, it was done correctly. One reviewer mistakenly said no or whatever. If it's, 0 yeses, say subjects, correct number of male subjects, 0 yeses, change the number of male subjects from the incorrect number to the correct number. So it'll just help you keep track of the changes that you've made. And this is what you need to do professionally when you revise your manuscript. So when I revise a manuscript, I go through every single thing that a reviewer has said, and I address what I've done to change it or why changes weren't necessary. So we'll mimic that, but it's in a much simpler kind of format. So that response summary, save those. The Word documents will be available on Canvas soon, and that's going to be due with your final research paper. So once you're done putting it all together, making all your final changes, you will hand in your research paper, and at the same time, you will hand in your 3 peer review summaries, one for the methods, one for the results, and one for the discussion section. All right, so that was a recap. Any questions on the library assignment or the peer review process? All right. So next class, we're going to have the in-class writing the results section. So this is one of those attendance highly recommended classes in the idea that if you miss this class, it'll be very detrimental to your understanding of what exactly is happening. So we will, together as a class, we're going to write part 1 of the results section. So I believe we're going to write up the results for percent recall. So we have 2 sections of results. We have one section for percent recall. What was the recall rate for false words in groups or in singles? And then we also have confidence level. How confident were people about their recall? So part 1 is going to be percent recall. We're going to write that together. And then after class, I will post this to Canvas. You will download what we wrote together and use that as a template to write part 2 of the results section, which is on confidence level. So that's the reason why we're doing part 1 as a class, because what you're going to find is that the results section is a very sort of structured way of writing. And there's no need to reinvent the wheel, and there's no need to make it interesting or captivating or use interesting prose. We're going to see the sort of metaphor to keep in your head when you're writing the results section, and you'll see why repetition is basically the best thing that you can do. So again, we are going to write this part in class together. I will be up here at the front on my computer taking dictation. You will be out there telling me what to put down. We are going to follow Ernest Hemingway's advice of writing drunk and then editing sober. So I will take your dictation and get something down on paper on our first pass, and then we'll go back and we'll make it sound pretty. So that's going to be the basic structure. And then when we're finished part 1, we'll end the class, and then I'll upload that, and you will literally copy and paste part 1 below it, label it part 2, and then change what you need in order for it to be a report of what happened in part 2. All right, so what are we going to report on? What goes into a results section? So in terms of the content of a results section, this is where you finally get to present the findings of your research. And by findings, what we mean is not the conclusions, but what are the actual numbers that we found? What are the actual differences that we found? What are the actual results? So the conclusions are going to come up in the discussion where you tell the reader what the results actually mean. This is where we just simply tell them what the results are. So there's not going to be any sort of interpretation of what we found. There's just going to be reporting of these 2 groups were different, these 2 groups were not different, these scores were here and these other scores were here, and that's it. So it's a very straightforward section to write because there's really no added interpretation to it. There's 3 ways to present findings to help your reader understand what's going on. We're going to use 2 of those 3 in our first draft of the results section, and then in your final draft you're going to add the 3rd. So we are going to have description in narrative form in our results section. We're going to tell the reader in as plain language as we can, describe to the reader what happened in our experiment. We're going to use statistical language, so we are going to talk about p-values and f-tests and f-statistics. Those are going to be means as well. We're going to talk about in our results section. And that's also one of the reasons why we're doing it in class, because I will have all that set up ahead of time, so you don't have to understand stats, but we will have that in our draft. And then in your final version, you will have either tables or graphs, but for this first draft, we're not going to need graphs or tables, right? So we're just getting stuff down on paper. We'll worry about putting the pictures in there later when you're handing in your final research paper. But for right now, we just want to get the words down, the structure down, the results section pretty much done without any illustrations. All right, so what we're going to be doing in this section, and this will become very apparent why we're doing it this way, is again, we're going to write section number 1. And section number 1 is going to have a very stable structure to it. And parts of section number 1 are going to be repeated over and over and over again. So we have 3 sets of results. We have what happened between false and true memories. We had what happened between singles, pairs, and groups of 3. And we had what happened when those 2 variables interacted with each other. And we are going to report those 3 things in the same way every single time. And the reason we're doing this is because the results section, you probably found this when you've been working through your required readings for your research paper, it's the most challenging section to read. The results section, even for a professional psychologist, after reading hundreds of articles, you slow down during the results section, and you have to take your time, and you have to really think about it. It's a very cognitively involved section to read. So because of that, we're going to try to make it as simple as we can for the reader, and we're going to do this by using structure that is very simple to go through. And importantly, we're going to use repetition, a lot of repetition. And if you take a look at structure and repetition, the best analogy for your results section that you have encountered in your everyday life is a children's book. We are going to write the results section like we're writing a children's book. So if you recall books like Goldilocks and the Three Bears, it uses structure and it uses repetition. So for example, Goldilocks saw 3 bowls of porridge sitting on the kitchen table, 1 big, 1 medium, and 1 small. So you see the structure, 1 this size, 1 this size, and 1 this size, and repetition, 1 big, 1 medium, 1 small. She took a bite from the big bowl. Yow, Goldilocks said, this porridge is too hot. She took a bite from the medium bowl. Ick, she said, this porridge is too cold. She took a bite from the small bowl. Yum, Goldilocks said, this porridge is just right. Notice the repetition. She took a bite from a bowl. Reaction, Goldilocks said, this porridge is something. She took a bite from a bowl. Reaction, she said, this porridge is something. She took a bite from a bowl. Reaction, she said, Goldilocks said, this porridge is just right. It's repetition over and over and over again. And the reason that this is done is because when you're a child and you're learning about narrative form and you're learning about story structure, it's hard to understand these stories. There's a reason children want to hear the same stories over and over and over again, is because they're trying to make sense of it. It still doesn't quite add up to them. They're still trying to process it. And what we do is we use repetition and we use pictures. We're going to do the same thing in our research paper. We're going to use repetition, where we're going to present statistics in the same sort of format as, she tried the big chair first. Oof, Goldilocks said, this chair is too hard. And then you repeat that structure again. She tried the medium-sized chair. Nope, Goldilocks said, this chair is too soft. So we're going to use repetition, and in your final draft, you're going to use pictures, which are the figures. So we're going to have figures in the results section. That's going to be the pictures from the children's book. But importantly, for next time, we're going to use repetition. So again, this is very understandable to a child. Imagine how hard it would be for a child if they were reading this story and it goes, she tried the big chair first. Oof, Goldilocks said, this chair is too hard. She then partook of the medium-sized sitting implement. Nope, Goldilocks uttered. This Chesterfield is far too unsupported, right? What's the child going to be sitting there thinking? The child's going to be like, I'm lost. I'm completely confused. Where's my structure? Where's my repetition? Well, why would we treat children fairly and nicely and then not do it for ourselves as an adult when we're trying to hold on to whatever we can reading the results section? We're going to do the same thing. It's probably going to go against everything that you've learned in writing English essays. So we're going to try to make our results section as boring as possible, as straightforward as possible, by using the same kind of language over and over again. So you might have to fight some inner kind of instincts or reflexes, but we'll do it, and we'll do it together. So the structure, the way that it's going to work, is we're going to start off with a conceptual definition. So we're going to start off with, in class, what were we measuring when we measured percent recall? Were we measuring the speed of memory? How much you could remember? How confident were you in remembering? So think about this. What was the aspect of memory that we were trying to get at when we measured what percentage of the words did you recall correctly? We're also going to, so that's the conceptual definition. we're also going to give the reader the operational definition. So we're going to say this is the concept we were trying to measure, and this is how we measured it. So how did we get to the numbers that we have? When we say that, oh, percent recall was 74%, how did we get to that 74%? How do we get to that actual number? So you'll have to let me know things like, oh, we added up all the correct words that were written down, and then we divided them by the total number of words that were presented. And that gave us percent recall. So start thinking about what it was that percent recall was measuring. How was it that we actually got to the numbers? Those are going to be the conceptual and operational definitions, respectively. Next section of the results section is going to be a summary in very plain English. No jargon, no overcomplicated language. It would be as if an intelligent individual with unfamiliar with the experiment but with a psychology background came to you and said, oh, I heard you did this experiment in P211. What did you find? What were your results? That's where we want this summary of the interaction in plain English. So we're going to say things like, oh, well, for the correct words, singles, pairs, and triples had the same amount of recall. But for the incorrect words, singles recalled this, pairs recalled that. So as simple as we can, just presenting the information in a narrative form in plain English. Once we have that narrative form in plain English, once we've given everybody a synopsis of what it is that they can expect, then we can go into the details. It's almost as if in the Goldilocks and the Three Bears story, you say, oh, well, there was this girl named Goldilocks. She went to this cottage that was owned by three bears. She tried some food. She tried their beds. And in the end, they came home and they kicked her out. We give them a synopsis of everything. Now they have a structure in their mind about what in general occurred. Then we get technical on them. Then we go into the results. And we say, oh, there was porridge. One was too hot. One was medium. One was too cold. There were beds. One was too hard. One was too soft. One was just right. That's where we get into the, oh, this difference had this F statistic. This difference had this p-value. And I will help a lot with the technical results. We'll have those all ready to go and already in the draft when we're going. But that's the kind of structure that we need. What happened, and then here's the technical results. Here's the evidence for it. All right. Any questions on that so far? All right. In terms of repetition, once we get into the technical section, this is how everything is going to go. We are first going to say whether there was evidence of an effect or no evidence of an effect. So, for example, if we were looking at the percent recall between correct words and incorrect words, right? Correct memories and false memories. You'll remember, hopefully, that false memories were recalled less than correct memories. So there was a difference. So what we would say, when we were writing up that section, would be that there was evidence of an effect. Yes, there was evidence of an effect. That is followed up by the statistical jargon. This is your evidence. You're making a claim. There was evidence of an effect. You then follow it up with statistics and numbers that would indicate, yes, here's your evidence that there actually was an effect. You don't have to know at all what those numbers mean yet. That's for P354 when you take your stats course. But we will have those numbers in there. And that's part of the reason, again, why we're doing this together as a class. So we got evidence of the effect, statistical jargon, and then we follow it up one more time with an English explanation. So if we had the result where we had correct items, and then we had the critical items, and we have percent recall, and that, I believe, was about 70%, and that one was about 40%. When we're writing that up, we will say, yes, there was evidence of an effect between correct and critical items. Here's your stats. F equals this, P equals this. And the English explanation. correct items were recalled at a higher rate than critical items. And that's it. That's the section for that particular difference. And then we do that. Oh, and then the last thing is you say, see the figure. We won't actually put figures in there, but it's a good idea to have that, oh, go see figure 1, just English language in there so that you know where to put your figures later on. And this is what we're going to do for correct versus critical. This is what we're going to do for singles versus pairs versus groups of 3. And this is also what we're going to do for the effect of singles, pairs, and groups of 3 on correct words, and singles, pairs, and groups of 3 on critical words. We're going to put all of that in the same repeated structure. And you're going to see once we write one of these, it's going to be very simple to write, the other two. All right, in terms of APA requirements, when I used to make students buy the APA manual, we used to do this, a little bit of this in class. Now that we have it all online, you'll be doing more of this on your own as part of the homework assignment. But just so that we know the APA requirements, first off, all the previous requirements are still in effect. So you will see that this results section has headings. It's got different levels of headings. It's got a level 1 heading and it's got level 2 headings. We are going to, and actually it's got level 3 headings, we're going to make sure that those headings are formatted. Still has to have the 1-inch margins all around, still has to be Times New Roman font. So all the previous requirements that we introduced in the method section, they're still in play. New requirements are going to be the following. For organization of the report, again, I'm going to do that a lot. That's why we're doing this as a class. But I would suggest rereading organization of a report, specifically the results section that starts on page 325 if your textbook is formatted the same way that mine is. In terms of abbreviations, that starts on page 341. We're going to introduce abbreviations. We might use them, we might not. We are going to use some statistical terms. So again, knowing how to format that is going to be one of the new things for the results section. So reporting numbers and statistics, this is actually going to be the one that is more prevalent or more relevant. We're going to report statistical terms. We're going to report p-values and f-statistics and means. We're going to report numbers. We're going to report percent recall. We're going to report, again, the p-values. We're going to report the f-statistics. So once we're done with the actual writing of it in class, as part of the homework assignment for this draft, you're going to go through it and say, all right, let me make sure that each of these sentences are in the proper APA format. Let me make sure that the numbers and the statistics are properly formatted. And then those are the only new things. Mostly it's going to be the reporting numbers and statistics. And then also remember double space, Times New Roman 12-point font, 1-inch margins all around. All right, so that is going to be the results section. There's your initial overview. Any questions on that? All right, so the last thing that I'll mention for this results section is that this is going to be, this is one of those very variable assignments that we do in this class where it will be as helpful as the input that we get the day of the class. So just to reiterate what's going to happen, I will literally be up here at my computer with the Word document open and on the screen here. And I will say things like, okay, let's start off with a conceptual definition of percent recall, what we were measuring, what kind of memory were we measuring, or what aspect of memory were we measuring, what should we write? And then I will open it up to all of you. And hopefully we'll have people putting up their hands saying things like, well, we were measuring, the aspect of memory we were measuring was the ability to recall, how much information can you recall? And that's what we were measuring. And I will write that down. The thing that we were measuring was how much, the ability of what we can recall in terms of how much information. I will get that down the first pass, right? Like I said, we're going to write drunk. Then once we've done everything, we're going to go back and I'm going to say, all right, this statement is true. How can we make it sound more scientific, more pretty, more easily understandable? The bottom line, though, is that I need input from you. So on that day, come in here, get your mindset, come prepared, get ready to talk. I will take dictation, but that is my role. I will act like a secretary up here at the front, taking dictation and helping us to put together this results section, which you will write via your input on that day. So I've had classes where we've had the whole thing done in about 45 minutes. I've had classes where we were not done after an hour and 15 minutes. Wherever we are, though, that's what gets uploaded to Canvas. So come ready to work, come prepared, get your mind set on that, and hopefully we will have a very productive results section. All right. Last thing I wanted to cover today, and we'll need this for the results section, is inferential statistics. So inferential statistics is what we're reporting in the results section. So what this is at its core is when you measure two groups on a variable, right? You measure two groups, correct words versus critical words. You measure more than two groups, right? You measure singles versus pairs versus triples. Whatever you measure on a particular variable, all you want to know is there a difference in the true score, right? Is it the case that in general, for humans, we recall correct items more than we recall false memories? Is it the case for humans that we work better in pairs and triples than we do alone? We have higher confidence or whatever it is that we're measuring. That's what we want to know. Is there a difference in the actual true score of what we're trying to get at? And if you remember, true score is what we're interested in, but we can't get there. We have measured score. And the measured score is what we can get to, what we actually measured on that particular variable. So if we were looking at depression, there's a true score, a true level of depression that these subjects would have. But then there's also the measured level that we have access to, and that is our measured score. So we're using the measured scores. How did people in this class do on percent recall to try to get to the true score of what is memory all about? So is there a difference in the actual true scores between two groups? That's what we're looking at when we're asking about statistical significance. So you'll hear people often say, oh, was it statistically significant? Did it reach significance? What they really mean is there a real difference between the two groups? Not a chance difference, not just a difference on their measured scores, but is there a real difference between the true scores on this particular variable? So is there a difference between the true scores, and how can we tell when you only have access to the measured scores? That's what inferential statistics does for us. It allows us to take a look at the measured scores and say something about the actual true scores. It allows us to take a look at the numbers that we have and say something about the actual truth of the matter. How does memory work? Not just for these individuals that we have in our experiment, but how does memory work for real? What is the actual true case of how memory operates? So once more, let's go back to the basketball example, because this is again what inferential statistics really does. It wants to find the true score. So if you wanted to know whether these two players are truly different in their basketball skills, do they really have a significant difference between their basketball skills, you would have a measured score if you had them play one-on-one. And if the difference was large, intuitively we're saying, all right, she really is, her true basketball skills really are better than that individual over there, right? Because this big difference on a measured score is highly likely reflective of the true inner score. On the other hand, if it was that difference between the two of them, well then we might say, well, her measured score is higher than her measured score. But in reality, their true scores are probably the same. There's probably no difference, no real difference between their true basketball scores or basketball skills, because this difference here is so small that it's likely that this measured difference is due to chance. It's due to one little fluke outcome. And then the last example, hypothetical that we had, is that if you have them repeat their game, even a small difference, as long as it's consistent, as long as this girl over here is consistently beating this girl over here, these measured scores tell us that she actually does have higher basketball skills. Her true basketball score is higher. Her true basketball skill is higher. Even though she's barely beating this other individual, she does it regularly. And inferential statistics will pick up on that to say that her true skill is actually higher than her true skill. And this is exactly what we did when I analyzed our results in inferential statistics. I took your true scores from your groups. You know, this group had this percent recall, this other group had this percent recall. And I took a look at the size of the differences, and I took a look at the consistency of the differences, and putting those two together using statistical inference, I came up with results that indicated whether your measured results indicated true differences in the psychology of memory. So that's what we mean by statistical significance. And statistical significance is oftentimes written as a number, and that number is known as a p-value. And if you talk to enough experimental psychologists, you will know that the p-value is the almighty final word that you're looking for in any experimental results. So that p-value is the make or break for your experiment. You get a p-value that's nice and low, you have found a statistical significant difference. Your experiment is a success. If you found a p-value that is too high, your experiment is inconclusive. It's oftentimes an unsuccessful experiment. So what is that p-value, that number between 0 and 1, and what you need to know about statistical significance? The goal of what you're trying to do in your statistical analysis is know whether the results you obtained are reliable. That's what we mean by saying that there's a true difference, that there's a real difference. Another way of saying that is that the difference is reliable, meaning that if we were to run this experiment again, we would find that exact same result, right? Maybe not exactly the same, not 70 and 40%. It might be 68 and 42% this time around. But correct is going to be higher than critical every single time. That's what we mean by a reliable result. So that's what statistical significance means. It's a test to allow you to make a decision about whether your obtained results are reliable, meaning that you are confident that you would get the same result over and over and over again. And that's why we look for sizes of a difference as well as consistency of a difference. So if I saw this game over here and the coach said, play it again. We're going to have you two play one more time. And the coach came over to me and says, who do you think is going to win? I would say, this girl, right? I've only watched one game, but it was 20-1, right? What are the odds that this is a chance occurrence? It's very, very low. So I would say that this girl is going to win. I would say that this result, this 20-1, that's reliable. This girl is probably going to win over and over and over again if you repeat this. In this situation over here, let's say that I just watched 100 games, and this girl won 100 times in a row. And the coach said, we're going to play it 101 times. And he calls me over and he says, which girl do you think is going to win? I'm going to say, this one. Even though she's only beat her by 2 or 3 points every single time, she's won 100 times in a row. The odds that she's going to win the next one is going to be very high. That's a reliable result. Her winning is a reliable result. This situation over here, if the coach pulls me aside and says, we played one game and she won 20-19, who do you think is going to win the next game? I would say, I don't know. Could be this girl, could be this girl, right? This is one lucky bounce. Maybe she'll win the next game. I have no idea. That result is unreliable. So that's what we mean by reliability. Did it get to the truth of the matter? Is there a real difference? If there's a real difference, then when you run this back over and over and over again, you should find that difference over and over and over again. It reflects the truth of what's going on. If it's unreliable, that means that there's probably no difference between the two. And if you run it back, it could flip-flop. It could reverse. So that's what we mean when we're talking about statistical significance. These two results here would be considered significant because they're reliable. There's a real difference between the skills. This result here, unsignificant, unreliable. Who knows if there's a real difference between the two? Make sense so far? Okay. So that was the first one. Secondly, your alpha level, or the significance level, as it's also called, indicates how confident you need to be in order to make the decision, right? So it indicates how sure you need to be about the reliability of your findings. And it just is the case in science that you can never be 100% sure. You can never be absolutely positively sure. There's always a chance that any difference that you find is due to a random event. There's always a chance that this difference that you found is due to a fluke result, not an actual real difference. So what we do in psychology is we set a significance level. We set a chance that we're willing to risk. We set a chance where we're saying, this is how much I'm willing to risk being wrong, to say that there is a difference when in fact there is no difference. And usually it's a 0.05 significance level or a 5% significance level. So what we're saying is that we will set a level where as long as we're 95% sure that there's a real difference, we're going to conclude that the findings are reliable, that there is a real difference. But it has to reach 95% before we're willing to say, yep, this is an actual real difference here. So when I say that there was a significant difference between correct and critical results, what I'm saying is that I am 95% sure that this is real, that this is an actual real difference. I'm 95% sure that this is not due to chance. It's not due to a random event. The thing to remember, though, is that you got that 5% chance you could be wrong. And that's why sometimes when you run an experiment again, in the literature, you'll find that people disagree. So that 5% significance level, that's what we're looking for. And the p-value is how confident you are. Basically, the p-value is what level did you get. So the 5% significance level, that's our line in the sand. That's the level of, that's the maximum probability that we're willing to entertain in terms of how wrong we are. The p-value that we get is the probability of how wrong we are. So just to put that another way, I'm saying that I'm willing to entertain a 5% chance that I'm wrong. That's what an alpha level of 0.05 means. I'm willing to entertain a 5% chance that I'm wrong. If my p-value is less than 5%, that's statistics telling me that you are less than 5% probability of being wrong. If my p-value is over 5%, that's statistics telling me you have a greater than 5% chance of being wrong. So 5% is my line in the sand. If my p-value comes in under 5%, then I'm willing to take that risk. If my p-value comes over 5%, I'm not willing to take that risk. And I'm not going to say that there's a difference. And that's inferential statistics in a nutshell. That's why you'll hear psychologists talking about their p-value, and they'll literally have conversations like, oh, I just ran the stats, on my experiment. And they'll be like, well, what was your p-value? And it's like, well, my p-value was 3%. They're like, oh my gosh, congratulations, well done, p-value of 3%. Excellent. And then somebody else would be like, oh yeah, I ran my stats. It's like, well, what about your p-value? Well, my p-value was 15%. Oh, well, maybe try some more subjects, run it a different way, change up your measure. Sorry to hear that. That's what they're talking about. That p-value just says, how likely is it that you're going to be wrong? And typically, we're only willing to be 5% wrong. Right? We're only willing that 5% chance of being incorrect. So, for example, back to the basketball situation. When I take a look at this result here, right, there is a probability, and you're going to have to just kind of use your mental imagination here. there's a probability that this girl over here got 10 lucky shots in a row, right? So it could have been that she got the ball and she panicked and she just threw it up in the air. And lo and behold, it went into the basket, right? There's a certain chance that that could have occurred. So now it's 2-0. So she gets the ball again. And once again, she doesn't know what to do with it. She just throws it up in another direction and it goes off the scoreboard and goes into the basket. 4-0, right? That could have happened 10 times, right? She could have gotten 10 incredibly lucky bounces. 20-1 would have been the final result. Highly unlikely that she would have gotten those 10 lucky bounces. So if we ran the stats on this, the probability that this difference was due to chance, that was due to fluke results, would probably be, what is this? That's 1%, that's a tenth, that's 100th, 1,000th of 1%. And that's being very generous, right? So that if I say to this coach, this girl is a better basketball player, I got a 1 in 100,000 chance of being wrong, right? I have a 1 in 100,000 chance that she just got lucky, 10 shots in a row. And I would be willing to take that risk. I would be willing to say, you know what, there's a 1 in 100,000 possibility that I'm wrong about this. That possibility is low enough for me to say, yes, she has the better basketball skills. You take a look at this situation over here. It could be that they have equal skills, in which case whoever wins here will be a coin flip, right? If they have equal skills, she's going to win half of the time, and she's going to win half of the time. So this individual wins once. The chances that she will win once is 50% if their skills are the same. So I would not at that point be willing to say, yeah, she's got better skills. What about 2 times in a row? Well, the chances of her winning twice is like flipping 2 heads, right? It's a 1 in 4 chance, it's 25%. What about 3 times in a row? Well, that's like flipping 3 heads in a row. That's an 8%, no, that's a 12% chance. So the probability of her winning 3 times in a row just by fluke, just by chance, is at 12.5%. Still not low enough. What about 4 times in a row? That takes it down to 6.25%. Still not low enough. What about 5 times in a row? Now we're finally below that 5% threshold. And if she played 20 times in a row, I think that's what I used, that's the probability of her winning 20 times in a row if their skills are equal. That's the probability of her winning 20 times in a row, basically on a coin flip. That's the probability that I would be wrong looking at these measured scores and saying that, yes, she is the better basketball player. That's less than 5%. I'm willing to take that risk. What about here? 20-19. Either she's the better basketball player or this was a chance occurrence. And because it's so close, the probability that you could get this result when their skills were the same is about 49%, right? This is basically a coin flip here. So the probability that she's the better basketball player is 49% right now. The probability that they're equal in their basketball abilities is 49%. That's way too high. That's way too high for me to say that there's a difference. So I will not be willing here, because this is way higher than 5%, I would not be willing to say that this difference indicates a real better basketball player here. I would say that those two have equal basketball skills, and this result is likely due to chance. And the reason for that is because the probability of it being due just to chance is higher than 5%. The probability of this result being due just to chance, way lower than 5%. So I'm willing to say that this indicates a real difference, she's better. Where I'm not willing to say that this indicates a real difference, she's better right there. All right, so that's the essence of statistical inference. Any questions on that so far? I know it's kind of like a lot to take in. Hopefully it'll all start making sense once we get into the actual writing of it. And then the third thing is for statistical significance that your textbook wanted you to know was that you're more likely to obtain a significant result when you have a large sample size. And that's one of the reasons why sample sizes, psychologists always want more subjects. You'll never hear a psychologist saying, you know what, I've got enough subjects, I've got 100 subjects, I don't want any more. Usually if they have 100 subjects, they want 150. If they got 150, they would love 200. If they got 1,000, they would love 2,000. And the reason for that is that the more subjects you have, the better you are at detecting small differences that are real differences. So the smaller the difference, the smaller the difference. Even if it's a real difference, the smaller it is, the harder it is to detect. And the more subjects you have, it's like having a more powerful microscope to take a look at these small little differences. So that's why in a situation like this, where there's a big difference, we know that that's significant. In a situation like this, where there's a small difference, it's not significant, right? We don't know if there's a real difference. But here, even though there's a small difference, we have a bunch of situations that all go into the same direction. This is just like having a bunch of subjects that we have measured that all go into the same direction. So because we've played multiple games here, even though the difference is small, that can actually detect a real actual difference between their skills. And this is the reason why we typically want lots of subjects in our studies. All right, and finally, you're more likely to obtain significant results when the effect size is large, and that's when differences between the groups are large and the variability of the groups, the scores within the groups is small. This is basically the opposite of what we just had. If you have a big difference, it's easy to detect. You don't need a lot of subjects. If you got a small real difference, it's difficult to detect. You need a lot of subjects. So this is an example of a big real difference. Large effect size. This is significant. We don't need multiple games to figure this out. Small effect size, hard to know if there's a difference between the two. Small effect size, right, because the difference is always very small. We needed the repeated games, we needed the multiple subjects to figure out that there was an actual difference in skill between the two players. All right, so if there is a difference in the true scores, once again, we call that statistical significance. If there's a difference in the measured score, but no difference in the true score, and in reality, there's always going to be a difference in the measured score, right? Every game is either going to be 20 to 19. Nobody finishes a game and it's like, oh, it's 20-20. You can't do that. Same thing in science. There's always going to be a difference in the measured score. But if there's no difference in the true score, then that's called no statistical significance. And importantly, for our results, we are not reporting when we say whether there's evidence of an effect or whether there's no evidence of an effect. We're not reporting based on the measured scores. We're reporting based on the statistical significance. If the statistical significance says that there's a difference, we say there's evidence of a difference. If the statistical significance says there's no evidence of a difference, we say there's no evidence of a difference. And that's going to come into play, for example, when we're doing percent recall, that's going to come into play in the interaction. Because when you compare the correct words recalled by individuals, by singles, when you compare the correct words in blue by pairs, and when you compare the correct words recalled by groups of three, the measured scores here are different, right? This is 70, this is 74, this is close to 80. The measured score is different, but what we report is the inferential statistics. Was it statistically significant? So in this case, we would say, yes, there was evidence of an effect of group size. Singles were lower than pairs. Pairs were lower than groups of three. That's what you report. You report the statistical significance. And that's going to be challenging and kind of go against intuition when we get here to the critical percent recall, to the false memories, because the measured false memories for singles was higher than the measured false memory for pairs. And the measured false memory for pairs was higher than the measured false memory for groups of three. right? So the measured scores here are different. But in the results section, we do not report the measured score when we're reporting, is there a difference? We report the statistical inference. And when I looked at the statistics, even though there is a measured difference between these two, the statistical test said the difference isn't big enough and it's not regular enough, it's not consistent enough. So there is no evidence of a difference between the percent recall for false words for singles, pairs, or groups of three. So when we write this up in the results section, we will say there is no evidence of an effective group size on false memories. Singles recalled just as many, or had percent recall the same as pairs. Pairs had the percent recall the same as groups of three. So we are going to report that, and you're going to have to fight the tendency to say things like, well, there was a difference in the actual scores, but in the statistical analysis, we found that there was no difference, or things like there was no evidence of an effect, even though there were differences in the actual numbers. That's all confusing. That's like going to a child and saying, this porridge was too hot, even though for a bear it would have been fine, and that's how the Papa Bear likes it, but for Dorothy, for Goldilocks, for her sensitive palate, because of the developmental sequence of a child, her palate was not, no, that's horrible for a child. They're gone, they're lost. The porridge was too hot. That's fine. Same thing here. Even though the measured difference is there, we're not going to say, oh, there's a measured difference, but it's not statistically significant. Keep it simple. No evidence of a difference. Singles recall just as many critical items as pairs, and they recall just as many critical items as groups of three. We will report the numbers. It'll be there. We're not lying. We're not hiding anything. We're just making it as simple as we possibly can. All right, so that was your primer for the results section. Next time, that was your primer on inferential statistics. Any final questions on any of this that we saw today? All right, so that is it for what I wanted to cover today. So again, next class, you don't have to bring any writing tools or anything. I'll be up here at the front taking dictation. I will print up handouts so that you have a summary of all the results, all the graphs that we need in order to write up this results section. But again, I will be taking dictation. You will be telling me what to write. So come prepared. Be ready to volunteer. The suggestions. And again, we will write drunk and edit sober. So don't worry about what it sounds like. We'll get something down and then rework it so it sounds pretty. And that's what we're going to be doing, I believe, next class. But other than that, we are done for today.